So what about pi bonds? What happens when we make pi bonds? Okay, well, just like we talked about in valence bond theory, these are linear combinations of now p electrons that are off axis, right? So remember, my internuclear axis, I'm going to draw this way, okay? So there would be my A nuclei, and there would be my B nuclei. And as I scale these close together, you can see here, I'm going to make a lovely pi bond on my Mathematica model here. We're waiting for it to calculate. Beautiful. And I think if I get it a little bit closer, it'll look like the classic pi bond. Okay. Yep. So there it is. Lovely. All right. And so we're going to call this, pi 2p in the Gen Chem days. But as I'm going to show you here in a moment, this is technically the 1 pi u. Okay, so let's take a look, right? So here is the linear combination I just made. 2p orbitals oriented in the same direction, right? With both positive lobes going. So we know that when we bring these close together, as shown here, the positive and the positive region will constructively interfere, and the negative region will also constructively interfere, which is why I get this picture right here. I get, lobes on either side of the internuclear zone. Well, if you look at my symmetry operation, that means my bonding state for pi bonds technically has odd symmetry. So we got to keep track of that. It's the opposite as the sigma bonds, right? And of course, I can't show you this on my model because my model is technically only 2-dimensional instead of 3-dimensional. But I could also make another set of pi bonds with 2 pi y. Okay, so over here, I'm going to call this 1 pi xu. Okay, and then I could also make another pi bond, which would give me a triple bond, right? If I had 1 sigma and 2 pi bonds, I'll call this the 1 pi yu. And we don't know which is which. It doesn't matter which one we call x or y, but what's important to note is it's not z. The 2pz makes a sigma bond, right? The 2px or the 2py make our pi bonds. And so now if we look at the anti-bonding state, let's go look at that. So that's going to be given by the subtraction. So you can see I've got it here. But now if I separate them, I've got 2 separate p orbitals. Okay, we'll let it calculate. And as I get them close to each other, they interfere destructively. So there's no enhanced electron density that's created between the 2 nuclei or even off axis from the 2 nuclei. I get these kind of 4 independent lobes that you can see right here. And it'd be the same situation for px or py. And then also, if we notice the symmetry operation, right? So we can see why these are anti-bonds. When I get these 2 things closer and closer, this positive lobe and this negative lobe interfere destructively, as well as this negative lobe and this positive lobe. So you can see that those have even symmetry. And so that's what makes this now the 1 pi x g and the 1 pi y g. Okay? So